Okay, so the question is find valid matrix given row and column sum. So you would be given two arrays, row sum and column sum, and row sum of I is the sum of elements of the ith row. Similarly, column sum of j is the sum of the elements of the jth column of a 2D matrix. Okay, so I do not know the matrix for which we have the row sum and the column sum, and what we need to do is find any matrix of non-negative integers of size this that satisfies the row sum and column sum requirements. Return a 2D array of any matrix. It is guaranteed that at least one matrix that fulfills the requirement exists. Obviously, by this we know there is no unique solutions. There could be a unique solution, but uniqueness is not guaranteed, because since you are compressing a 2D array into two 1D arrays, you are losing out on information. So if you see this first example, you have one output is like this and the other is this. Both are satisfying the row sum and column sum properties, but we have two possible answers. So okay, so how I would go by is I would go to each element, take the element at the row sum, and let's say we are at an element ith row and jth column. So what I would do is I'll take row sum of I and column sum of j and find the minimum of that and place that in the new matrix, and then I would subtract the elements. That is how I'm thinking I would go by this. So for that, let's start to write the code. So int m is rows. Let's say it is row sum dot size, and similarly for number of columns is n, column sum dot size. Fine. Now what I need to do is generate that 2D matrix that we have to return. So for that, I'll declare a vector of int, and let's call this as answer. And to initialize this, I would say it has m rows and each row is of type vector int and has n columns. M rows and n columns, right? Fine, this is great, and in the end we have to return this answer matrix. So that is what we do. Now what I do is traverse through the matrix. So for int I is 0, I less than m, I plus plus. Similarly for traversing the columns, int j is equal to 0, j is less than n, and j plus plus. Now what I do is calculate the minimum element of both row sum of I and call sum of j, and since we need to find the minimum, let's say minimum of them. Okay, so after this, what I do is I say answer of I and j is this mini, and since we've used this mini, we have to subtract this from row sum of I and column sum of j. So also note that the matrix should have non-negative integers and row sum and column sum should be positive, obviously. So what I do is I take row sum of I and I say minus equal to mini. I subtract that value, and same for column sum of j. Okay, now I think this should work, because by the end of this iteration you would have every element of the row sum as 0 and every element of the column sum as 0. So let me check. I don't think there's an issue. Let's try to run this. Okay, we missed a semicolon. Let's format this code. Then again, let's try to run this. Okay, this works. Now we'll just submit this. Yep, accepted. Now what we'll do is we do the same thing but in Java. So what I'll do is copy the exact same code. I go over to the Java section and I'll just paste this. Now there are few differences in the syntax, and let's say in place of size we have length, and it's not a function but an attribute, length. And for the vector, we cannot declare it as a vector. We can say int answer is equal to new int m and n, because everything in Java is an object. We treat it like that. So okay, now we can delete the vector thing. Okay, now we go over this and we return the answer. Only difference is use math.min, or you can manually just check by if and else condition. I'll just run this and this should also work. Yep, this works. Let's just submit this. Okay, yeah, great. So now what we do is, again, I take the same code and I'll do this for Python. I'll just paste this and oops, let's go over to the C++ code, copy everything, Control C, and Python, I'll just Control V, and there are only a minor change, but there is no declaration of the data type for variables, and say here as well we don't need this. And yeah, for the getting the size of elements, we use the length function, length of row sum and length of column sum. Again, we cannot use this vector, so what I do is create a 2D matrix using list comprehension, and that is done as follows: 0 for I in range m, for j in range n. So m, okay, so other way around, this is m and this is n, so we have n columns and we have m rows of that stuff. Okay, so we don't need this. Now we have this. Also, if you observe, we are not using I and j in this list comprehension, so you can replace this with underscore to get a wildcard character. Also, you don't write for loops like this in Python, so you go like say for I in range m, for j in range n. You do this operation. There are no curly braces, there are no semicolons, and you just return the answer. This should also work. Let's just run this. Accepted. Now we just submit this and I think we are done for the day. Accepted. So this is what we do, and let's go with the time and space complexity. So we are going through each an element once, right, in this thing, and also every operation in that element is taking constant time, so big of one operation for every element. So net time complexity would be big of n square. Also space complexity would be big O of 1 for solving, but to return the answer we are using big O of m times n, and time complexity would be big of m times n, not n square but big O of m times n. And space complexity would also be the same, because we have to generate a matrix, we have to allocate memory to it, and we have to return that. So space complexity is big of m times n, but to only save the answer. But to solve this, we only need big of 1 space complexity. Same is for, because we used exactly the same code, so the time and space complexity is also same here, and even in Java Python as well. Yeah, thanks for watching. Bye.